Welcome to question 9 of the 2012 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For part A, we're asked to let the function with a domain of R have the rule f of x equals x sine of x, and we are asked to find the derivative f dashed of x. So inspecting this function, we can see that it's two functions multiplied together, so we're going to use the product rule. And to help apply the product rule, we're going to let u equal x, which is one of the functions multiplied, and v equals sine of x, which is the other function that's multiplied together. And next we calculate du dx, which is going to equal 1, and dv dx, which is equal to cos of x. From the formula sheet, we know the derivative d dx of a function u times v is equal to u times dv dx plus v times du dx. So therefore, f dashed of x, the derivative we're asked to find, is going to equal u times dv dx is x times cos of x. And then we add on to that v times du dx, which is just sine of x times 1, which is simply sine of x. So that is the answer for part A of this question. From the examination report, we can see that 79% of students got that correct, and that the examiner goes on to say that it was generally well answered. For part B, we're told to use our result from part A to find the value of the integral between pi on 6 and pi on 2 of x cos of x dx in the form a pi plus b. And now we're asked to use the result from part A because we need to use integration by recognition to get an antiderivative of x cos of x, because it's not a formula that we have on our formula sheet. So the information we had from part A was that derivative d dx of a function x sine of x was equal to x times cos of x plus sine of x. And now if we were to integrate both sides of this equation with respect to x, we would still have an equals statement. Now the integral of a derivative just leaves behind this x sine of x, and we know that's going to equal the integral of x cos of x dx, and I've just put that in purple because it's starting to match up with what we need it to look like. And we still have plus the integral of sine of x dx. So next up we can evaluate this slightly further. So x sine of x is going to equal the integral that we want, which is x cos of x dx. And then the integral of sine of x goes to negative cos of x. And now I'm going to leave off the plus c because we're going to use this in a definite integral in a moment. So therefore, an antiderivative for x cos of x dx is equal to x sine of x plus cos of x. So we're going to use this antiderivative to calculate the definite integral in the question. So now, with just a bit of blank space to do the next stage of this, we're going to have the integral of pi on 6 to pi on 2 of x times cos of x dx. And we know from the previous page that that is equal to the antiderivative of x sine of x plus cos of x. And we're going to evaluate that between pi on 6 and pi on 2. So to evaluate that, we're going to substitute in the upper terminal first. So wherever there's an x, we're going to put pi on 2. So we have pi on 2 times sine of pi on 2 plus cos of pi on 2. And then we subtract away that, the lower terminal substituted in. So we're going to have pi on 6 times sine of pi on 6 plus cos of pi on 6. And now, remembering our exact values, sine of pi on 2 is simply 1, and cos of pi on 2 is 0. Sine of pi on 6 is equal to a half, and cos of pi on 6 is equal to root 3 over 2. So this is going to equal pi on 2 times 1 plus 0, so that's what was in the first bracket. And then we subtract away from that what was in the second bracket, which is going to be pi on 6 times a half plus root 3 on 2. And now we need to put that in the form a pi plus b. So we're going to have pi on 2 in the first bracket, which I'm going to write as 6 pi on 12, so I have a common denominator with what's in the second bracket, because we have minus pi on 12 comes out of there, and we also have minus root 3 on 2. So we almost have this in the form that we want, so 6 pi on 12, take pi on 12 is 5 pi on 12, and then we're going to have subtract root 3 on 2, which is that b term. So that is the answer to part B of this question. From the examiner's report, we can see that 45% of students got full marks for this question, so it was reasonably well done. And now the really important comment we can see in the examiner's report was that students needed to provide the answer in the required form of a pi plus b.